Okay, big question here. We've got a 10 marker. So it's a fair amount to do. Also, we've got this, you'll be assessed on the quality of written communication. So you've got to be think about the way you write this. So they've actually given you a formula to start off, which means that we're going to be using, at some point, the volume of a cone. Okay, so at some point we know that we are going to be using this. So a thin piece of card in the shape of a sector has a centre north, a radius of 5. So centre north, radius of 5, as shown below. The card is used to form a cone by sticking OA and OB together, right, okay, with no overlap, such that the arc AB becomes the circumference down there. So we can say arc AB equals the circumference of the circle. Okay. Calculate the volume of the cone, correct to 3 significant figures. Now, if we are going to find the volume of the cone, we need the perpendicular height, which we don't have, and we need the area of the base. So the area of the base should be pi r squared, so we need the radius, which we don't have. Okay, so there's nothing there in this circle, in this shape at the moment that we've actually got that we need to use. So we're going to have to start on here. And the thing that I'm going to start with is the thing that they have suggested, which is about the arc length AB. Okay, so the arc length is this around here. Okay, so that's my arc AB. And that matches up with this circumference of this circle. Okay, so those two are the same. So if I can work out the arc length, I've got the circumference of the circle, and I can go from there. So, the arc length of AB is theta over 360. Because it's a fraction of this whole circumference, okay, it's 110 out of the 360 of this whole circumference. So it's 110 out of 360. Multiplied by pi times diameter. And the diameter of this shape, if the radius is 5 centimeters, the diameter is 10 centimeters. So we get 110 over 360 times pi times 10. And we can pop all that into our calculator. So we've got 110 over 360, lots of pi times 10 is 55 over 18 pi. And that is in centimeters. Okay, so this is my arc length. So that means that my circumference of the base of the cone is also going to be 55 over 18 pi centimeters, because they're the same. So let's now try and use this. I know that the circumference of a circle is pi times diameter. So pi times diameter of the circle now is 55 over 18 pi. Now my first step here would be to divide both sides by pi, because if this has got a pi in it and that's got a pi in it, if I divide both sides by pi, they'll cancel out, leaving me with the diameter is 55 over 18 centimeters. And that means that I can then find the radius. So the radius is half the diameter. So I just divide that by 2, which is 55 over 36 centimeters. which doesn't give us a nice answer, so I'm going to stick with the fraction. So I now know that this length here was 55 over 36. Okay, if I want the volume, don't forget, if I want the volume of the cone, I need 1/3 of the area of the base. I can work out the area of the base now. That's fine, because I got the radius, but I also need this perpendicular height, which I don't have. So I now have to look at this triangle. Okay, so if I look at that triangle, so from the cone, and you want this to be clear that this is coming from the cone, so let's just say this is from the cone. We have got O at the top. We've got A and B at the bottom. So O, A and B. And this is the centre of the circle. Okay, that's a right angle triangle. And I know this was 5 centimetres. And this was 55 over 36 centimetres. So we can now use Pythagoras because we've got a right angle triangle. We know 2 of the sides. We're looking for the third. So turn our right angle into an arrow, takes us to my hypotenuse. The other 2 sides are A and B. So if I want to find the height of the cone, I need to use Pythagoras. So A squared plus B squared equals my hypotenuse squared. So that's my A squared plus 55 over 36 squared equals 5 squared. Okay, so if I work out what my 55 over 36 squared is, and I take that away from 5 squared, that actually leaves me with 22.7. And if I square root the answer, it gives me 4.76 centimetres, because it's the height. Okay, so now I have got the height and I can work out the area of the base. So I can now ready to use the volume formula for a cone. So the volume of a cone equals 1/3 of the area of the base, so pi r squared, times by the perpendicular height. And if we put in all our information, 1/3 times pi, lots of, well, the radius was 55 over 36. Times by the height, which I've just worked out up above, 4.76. No, that's not exactly 4.76. So I'm going to be using the answer button on my calculator. So if I tap all that in, I get 1/3 lots of pi, lots of 55 over 36, times my answer is 7.62 centimetres. So just check if it asks for a certain degree of accuracy. Oh, 3 significant figures. So that is what I've done, but I'll just show you what's happened. 7.616847.203 centimetres, and to 3 significant figures means after my first significant figure, which is the first one that has any sort of value, so it's this one, that's my second, that's my third. Essentially, then if that's my cutoff after my second decimal place, I'm rounding to 2 decimal places. So 7.62 centimetres to 3 significant figures.